you think that's a good, a good start? Is that how we would start if you're just laying out your ingredients to say, well, what one could represent bedrock, or which one do you think would be topsoil, and help them recall the information that they've been learning in their lesson. And once they have built it, it's also like a good recall. Okay, what was first? What was second and third? Then they could go, I know in first grade we do a lot of labeling. They can then drag the label to the corresponding horizon as well. And the last one for this one is in preschool, and I have a 4-year-old going into preschool this fall, a secret word. So how can we get gardening and soil and sciences into those pre-K friends? And this is something that is definitely a winner for me, at least in my house it was. For a secret word, friends, all right, now what is this right here? What is this animal? What is that? It's a snake. What does snake start with? So then they could, one, tell me that they know the beginning sound of S. Then can they identify it? Show me that on the alphabet chart, or show me on your chart at your seat. Great, yes, you can tell me the beginning sound. You hear it, you can show me the letter identification. Now can you write it for me? So then they can show you how well they can do their letter writing. Also, if I know, I have up here a little cheat sheet that I know fine motor is still something that is being very worked on. However their background was before coming into a preschool setting or even a kindergarten setting, you can do traceable letters and then cover with a sticky note so that they are still able to say if they can hear the sound, identify that letter sound, and then you can pull it up to show that they can have assistance in writing and forming that letter. Okay. All right, I'm gonna stop sharing that screen and come back to you. Okay. The last activity that would be for maybe higher grades, I would do this with my littles in a different fashion. This is a spinner. Ooh, can we see? There we go. Sorry with the glare. I would do a spinner, and on here on this one, all it is, oops, wrong layer. It's a removable chart sheet, and I used a dry erase marker. This is laminated to change it up as needed. And I put the horizon names on it, and they could spin a reel. All right, topsoil, tell me about it. What did we learn about that? What letter is associated with that horizon? So you could do it that way, and they could just do recall and definition. Another student could have a spinner with the letters, the O, A, B, C, R. And all right, you spin, friend. All right, you have letter C. Spin over here. Do those match? Did you make a match? Yes or no? Tell me why. So that's another way that you could use the spinners in the classroom. I also just recently saw, for older friends, that if you had actual availability to use different parts of the soil profile, you could label that on cardstock, and using double-sided tape, put that on one side and peel the tape up little by little and sprinkle those each layer examples down as you go. And then they have a real life example under a microscope and a lab if you have those capabilities. All right, now we're going to compare and contrast. Let's throw in some grammar in there. Let's throw in some language arts. How does that feel? Does it crumble? Is it large granules? Is it small granules? Give me some adjectives. Is it smooth? Does it feel like sand? Does it feel like something you've ever felt before? Salt, maybe. So those are all those different ideas that you could use across the grade levels, and of course, based on what is best for your students that you have at the time.
Wonderful. Thank you so much, Becca, for sharing those resources and activities. And just so everyone knows, she did make those nice little sheets that explain where everything is from and how to do everything. So you'll be getting them all in your resource packets. So thank you very much, Becca. And now we will be moving over to Melissa. So if you would like to start your presentation. Thank you.
Thank you, Cassidy, and thank you, Rebecca. That was really awesome. So I am both a soil scientist and a mom, and I think that my kids would really find that an awesome and interesting way to get started talking about soils. I'm going to continue that conversation with you, and I think my main emphasis today really is going to be sharing resources with you so you can learn more and teach more about soils. And a handful of key points that are interesting to anyone starting this discussion, the soil profile and the textures are listed here. I probably got too excited and have too much to cover, but we'll see where we get. The best way to learn about a soil, of course, is to go outside, take a walk, dig a hole, and touch the soil. The tools I use as a soil scientist are a soil auger, a soil probe and shovel, and a mechanical equipment, a track hoe or a bulldozer even, to dig a hole for me. I would love to be able to take you all out and dig a big hole, a soil pit, but this probably is not going to be a good year for field trips. Maybe social distancing, we could do some outdoor activities with small groups. But as an alternative, I do want to share some really great video resources that are available to you to bring the soil home. You will find a lot of these resources for educators on the NRCS Soil Information for Educators, the Soil Science of America, and also the Pennsylvania Envirothon Soils page. And of course, your internet browser, if there's any subject you're interested in, you can find it. And I really recommend going small video clips, small pieces to keep people's attention. You can find a lot of great lessons that are just 2 or 3 minutes. And I'm gonna show you a few that I thought were pretty interesting and a really good launching point for further discussion or activities or additional learning. I'm gonna start with one of the Soil Society of America videos. In 2005, they did a great video series where they did a small short video for every month of the year. So we're gonna start with the basics. And Cassidy or someone shout out if you cannot hear or see my screen.
Let's start with the basics. Soil is one of the 4 things that we can't live without. Soil, water, air, and sunlight are all needed for life as we know it. Soil plays a role in providing our food, our clothing, and our shelter. Soil is a living resource that has formed at the surface of the earth over millions of years. Soils are dynamic, and they change with time. Their parent materials could be bedrock that's weathered in place, or sediments and smaller materials carried by flooding rivers, moving glaciers, or blowing winds. Over time, sun, water, wind, ice, and living things like plants and animals help transform the parent material into soil. Through the years, precipitation adds water to the soil, and dust and rocks add minerals. Plants and animals add organic matter and nutrients. But the water evaporates, and plants also remove nutrients from the soil. And soil particles can wash away in the rain or blow away in the wind. This is why soils are dynamic and changing with time. Soils are also full of life. Did you know there are more organisms in a teaspoon of soil than there are people on the planet? Soils have a partnership with the organisms that live in them. They each help to keep the other healthy. Soils, along with the organisms that live in soil, provide benefits to our planet.
Okay, I'm going to stop there. Just kind of catch your interest. These are small video clips and they're pretty cool. I'm going to go back to my presentation if I can find it here. Let's see. Or I'll stop sharing and share again. Okay, so that was just a 2-minute video we looked at, but it introduced us to a lot of interesting ideas that we might want to explore further. And a student might say, okay, tell me, what were 3 things that we learned? We learned a little bit about how soils are formed. We learned a little bit about some of the ecosystem services, what soils provide for us, and some of the regulatory services of soil. Maybe we just got to look at soil and we noticed it was under our feet and it was a lot of different colors. It's a launching point to say, hey, what was interesting about soil that he just talked about, and what would I like to know more about? So what if we want to know more about a soil profile? We can go and do some research and find some resources and present a PowerPoint presentation, or do a really nice activity like Rebecca shared with us. And here's another video clip, very short and just a nice summary of what is a soil profile. So going back to sharing again. Let's see.
A vertical layer of soil that shows all of the different layers is the soil profile. Much like your profile on Facebook, it tells others all about you. The profile of the soil tells all about the soil. A soil horizon is each individual layer of the profile. Each layer has different physical properties. The horizon layers are O, A, E, B, C, R. Let's take a look at what each layer is made up of. The O layer, or horizon, is also called the litter. It's composed and contains dead leaves, twigs, sticks, fallen trees. The O horizon is thin in some soils, thick in others, and not present at all in some types. The A horizon is also called the topsoil. It contains rich organic matter along with some minerals. This layer contains decomposers. The decomposers perform the task of breaking down plants and animals. The remains of these plants and animals create a mixture called humus, which is dark organic material that forms in soil when plant and animal matter decays. E is also called the eluviated layer. As water moves down the soil, substances are removed and pulled out in this layer, resulting in a concentration of sand and silt particles. This layer may be missing in some soils. Horizon B is called the subsoil. It's lighter in color. Many times it's reddish or brown in color because it has less humus. It is a zone of accumulation where materials like clay collects from the movement of water downward. C horizon is the parent material. This layer contains much of the material that the soil was originally made from. It will contain rock fragments. Weathering breaks down the parent rock into smaller and smaller pieces of rock, and this layer is most often light in color. And then horizon R is the bedrock, a massive rock such as granite, basalt, or quartzite, limestone or sandstone that forms the parent material for some soil.
Okay, so that is a nice discussion of the basic concept of a soil profile. And if you know any soil scientists, you may know that we are an introverted group. We go around and we spend a lot of time alone in the woods, on the cropland, looking at soil, not talking with a lot of people. So I guess as an educator, you have more experience getting in front of people speaking about these things. As a soil scientist, it's kind of exciting that I can find videos to explain these things that I might not feel as comfortable talking about. Even though it's something that I should be an expert at, still that idea of being extroverted and engaged with a large audience of people, it's how I'm more comfortable presenting material. So I shout out to our teachers that have to present this information in front of groups of people every day. These soil horizons, these colors are beautiful. And it's interesting at any level, but to talk about what makes the colors different. The humus, the dark, rich organic matter that accumulates, especially in a wetland soil or an organic soil. How the water table and the drainage of a soil really affects the colors. The soil modeling, the grays and the where the air hits the iron, the oxidized or rust colors we see in the soil. We can learn a lot about a soil profile just looking at the colors and the different layers. Here is a typical well-drained, bright brown, aerated soil where all the iron and bright mineral pigments are present. And then what a soil looks like in a wetland, a soil that is holding water most of the year. It forms with different colors, with the minerals washing through and exposing differently. Soil scientists use a special nomenclature, a Munsell color chart. It looks a lot like the paint chips you go to choose when you paint your walls. And it gives us a scientific way to describe the dark browns or oranges or yellows we see in the soil. And now we're going to touch briefly on another fun way to explore soil, and that is texturing. Something that you can watch a video and see how to do it, but you definitely should try it at home because that's the fun part, to really touch. And you would probably be able to ask your students to go out and find a shovel full of soil, or you might prepare bagged samples in the classroom that students could come in and pick up a sample and take it home and try a texturing exercise.
Clay loam. It's possible to analyze and classify a soil according to this chart in the lab, but you can also get very close to determining the actual makeup of a soil with your bare hands and a little water. The easiest test is for sand. If you can wet a small pile of the soil in your hand and not be able to shape it into a ball, you have a relatively pure sand, less than 10% each of silt and clay. If the soil forms a ball but will not hold together as a ribbon, it is either a loamy sand or a silt. The way you decide is by rubbing it between your fingers. A loamy sand will feel very gritty because it's almost completely composed of large particles, while the silt will be completely smooth. If the wet soil easily retains the shape of a ball, can also be squeezed into a long ribbon, and feels sticky, hard to squeeze, and shines when rubbed, it's at least 35% clay and is somewhere at the top of the chart. If, in addition, it feels very gritty, it contains more sand than silt and is probably a sandy clay. If it feels very smooth, it's probably a silty clay, and if it feels only a little gritty, it's a clay. If your soil forms a ball and a ribbon only 2 to 5 centimeters in length, or is somewhat sticky, it will fall somewhere in the middle of the chart as a variety of clay loam. Rub it between your fingers to judge whether it is sandy or silty or in between. If the ribbon breaks at less than 2 centimeters and is soft, smooth, and easy to squeeze, it belongs at the bottom of the chart. Again, it's either mostly sand, mostly silt, or about equal proportions of both. The best way to learn how to hand texture soil is to practice on soils that you already know the texture of. Ribbon.
So there you have it, soil texturing. So our soils, our textures, are actually referring to the particle sizes of the soil, the different minerals. If we have really coarse textured, larger particle sizes, those are our sandy soils like we find at the beach. And then we have next in growing or decreasing in size, the silt soils, which are very flowery to feel. And then the smallest of all are the clay particles, which we could not see with the naked eye, that are very sticky and tacky. But our soil, for the most part, is a blend of all of these different particles. Though in some areas, such as the beach or in a wetland area, you might have predominantly clayey or predominantly sandy soils. And the dominant texture of the soil is really important for how that soil will function. If you are using that soil to prepare for some kind of engineering practice, like building a road, or it will help you anticipate what soils, how it will be performing in an agricultural setting. Another interesting way to evaluate the soil particles in a soil is just a bottle of water, half full, and to put a clod or a handful of soil into that bottle of water, shake it up, and let it sit and watch the soil particles settle out. Within minutes, the sand particles will rapidly settle to the bottom, the largest particles. And then over another period of time, 3 to 5 minutes, you'll get a thin layer of the silt particles that will rest on top of the sand at the bottom of the bottle. The clay particles, the very small particles, will stay suspended in the water, and they may take even a day, the next day, until they're completely settled out. This suspension of the soil particles in the water is also an instructive exercise for how soil sediment can act as a pollutant. When we have a storm event and it washes the topsoil from a field into the water, that suspended soil makes the river water or the streams brown in color. We have that suspended clay and silt in the water being carried away from where it needs to be on the topsoil into our water, where it acts as a pollutant. Another exciting area of soils is the life or the microorganisms within the soils. This is something that students can explore at home or with a shovel of soil. Take a shovel and look at the topsoil. Do you find a worm? Do you find ants? Do you find burrowing creatures or decomposing leaves and litter? And this is a cool video that shows some of that life.
There, an entire kingdom lies beneath our feet, all clustered around the roots, the rhizosphere. Colonies of bacteria, fungi, nematodes, amoebas, pillbugs, springtails, millipedes, and earthworms. More than a ton an acre, together weighing about as much as their above-ground counterparts. Grazers, browsers, shredders, decomposers, predators, and prey. In the soil, something will eventually become food for something else. The byproducts of all these life cycles, that's what feeds the plants. What powers these kingdoms? Solar energy. Carbon dioxide becomes sugars, goes to the roots, and is exuded to feed and power these underground kingdoms. What is a living soil? It's where the plant and the soil are one. This is symbiosis at its best.
Okay, so we got to learn a little bit about the soil web and the relationship between the microorganisms and the plants, how those living creatures and the things we can see and the things we can't see have an important role in cycling nutrients through the soil that our plants agriculturally, our trees need to grow. In addition to those ecosystem services of cycling and cleaning and using nutrients in the soil. And this is just another graphic like the food web. The different roles that these microorganisms play are decomposers, are nitrogen fixers, the bacteria, the fungi, how all of these things within the soil are busy, hidden beneath our feet, performing these important functions for our environment and for our agriculture. A very important part of soils is soil conservation, of course. Building soils, maintaining soils in their place. So important for our population, securing an abundant food supply for today and for generations to come. Really understanding that soil provides a service where it is, and we don't want to lose it. And when we don't protect the soil, you know, it's at our own peril. We lose all the wealth and the fertility in our farms, and we end up polluting our waterways and bringing chemicals and nutrients and sediment into our clean water. So soils are historical. Another interesting lesson to go find on the internet is the story of the Dust Bowl and how those actions in the 1930s, coupled with climatic events and droughts, really caused a terrible combination of dust storms and devastated agriculture and devastated the environment in the 1930s. These cultural and environmental conditions led to the formation of the soil conservation districts that are today the Natural Resource Conservation Service. And these are the same services that are promoted and practices that are important to agriculture today to maintain healthy ecosystems and environments where we have fertile, abundant farming side by side with clean water. So you'll find a lot online about soil health. And there are a series of really short soil health in a minute videos. And this is one of my all-time favorites. It's really fun to do as a live demonstration, but the video captures it pretty well.
I have a question to ask you. Is your soil healthy, functioning, and stable? One of the best visual diagnostic tools that I know of is the soil stability test. Here are two soils, exactly the same soil type. This soil has been tilled for 30 years. This soil has not been tilled for 40 years. It is covered with diverse plants year-round. Watch what happens when we drop the soil in the water. Notice how the conventional till soil is falling apart. The biotic glues in the organic matter are burned up by tillage. The soil pores have collapsed. Notice the no-till soil. The pore spaces are still intact. Do this test for yourself. I guarantee if you dig a little, you'll learn a lot.
So this is a really important demonstration that we use with our farmers and landowners when we talk about conservation tillage and no-till. Just a role that farmers play in our communities of really protecting our soil. And that is, you know, their tillage practices, they're using cover crops, keeping the soil covered in the winter, not applying manures and tilling the soils before stormy seasons and storm events. And that healthy soil just really side by side comparison really impacts our water quality. And our agency, the Natural Resource Conservation Service, spends a lot of time providing technical and financial assistance to help farmers use cover crops and convert to minimal tillage practices so they can really have healthy soils and help us have healthy water. To learn more about Pennsylvania soils, you can go online. Hazelton is the Pennsylvania state soil. There's many different kinds of soils in Pennsylvania, and the soils really vary by geography. The different kinds of geology formations, the different kinds of landscape positions shape what kinds of soils you find in different places. At a small scale, we can do a soil map, and if you overlay the lines, the soils change just depending on landscape. So if you're at a high point up on a hill, you're going to have different soils than you would down in a draw, a low area, or a floodplain, or a depression. So soil maps go hand in hand with topology and geology. Soils, we describe the smallest unit of soil as a soil series. And when we draw these soils on a map, we call them soil map units. And this is how we read about a soil on a soil map. So we would see a symbol, and that would stand for a soil series whose name is Clinesville Shaly Silt Loam. It's 3 to 8% slope. And if we read a little bit more in a soil map, we would learn that this soil that is mapped here is 90% of the time that soil, but it might have minor components or other parts of soil within that. It's not a pure sample, not a pure map unit. And we learn a little bit about, in a map unit description, about the soil, about the parent material, about the landscape position, where we expect to find that soil. The soil survey is a great way to learn about soils online. The Web Soil Survey is the official database for the United States for all of our soil surveys. So you can find soils information for any state, for any county on the Web Soil Survey. And you can print your own custom soils map for your school, for your home. You can type in an address and print a soils map. Before the digital age, we had old soil survey manuscripts or books. You can still find these at the library to see and hold hard copy maps of the soils. Today, these old hard copy soil surveys are archived online, and you can find a digital copy of the soil survey. You would type in the NRCS Field Office Technical Guide, or you could probably just type in archive old soil survey and find that information as well. You could also contact your resource soil scientist to learn more about finding soils information if you need help with that. So every county has a soil conservation office, and I work in the state office. You could contact the NRCS for assistance using soil survey. Really, one of my favorite ways to use soils right now is the soil web. And I'm just gonna share my screen again. You would just go in your browser and type soil web. And you can do this both on your smartphone, or you can do it on your computer on Google Earth. So you would either just type in soil web and choose the app and do this on your phone, or you can do it in Google Earth. And I live in Hershey. I'm gonna type in Milton Hershey School. And you probably have enjoyed looking at maps and looking at places with your students. But when you use the browser and go into Soil Web first, it allows you to load the soil file onto your C drive. It just says download and save. You say yes, you save it to your C drive, and then Google Earth launches and you can immediately see the soil lines displayed. And what's so nice about the Google Earth interface is you can interactively just click and learn about the soil. So if I click here, that CR map unit is a croton silt loam, occasionally ponded, and it tells me that 80% of that is croton, but it would also have minor components of other soils in there. And then if I want to learn more about the series, I click on the name again. And Google Earth brings in a soil profile, what typically I would find. It gives me information about if it's a hydric soil, a wetland soil. And then for high school students or middle school students, it gives information about limitations. What is this soil good for? What is this soil bad for? So if it is well suited, it would be a good soil for some forestry properties. If it is very limited, it would not be a good soil for something like excavating ponds or building dikes or levees. So you could have, within the web soil survey environment, you could produce soil reports or maps, but you could also, through Google Earth, just interactively find out, is this soil good for these activities? So I'm just gonna click the back arrow. It brings me back to my map. And it's a good way for a professional also to go out to the field if you don't have time to gather up your maps and do your research. I have a Soil Web app on my phone. And it just geolocates my position and I can see the soil where I'm standing and get some additional information if I'm in a new place and not familiar with the soils there. So they did a good job here. They built the school up in the high point, not in the wetland that we just looked at. And if we click on that soil, that's a Hagerstown soil. And we see our soil profile. It tells us our land classification, but it's also going to give us some ratings. And if we went into building construction and information like that, we would find that it's a lot better than the wetland soil we were just looking at. However, it might have limitations that a builder might want to be aware of. For example, if they are looking for a source of gravel or a source of topsoil, or they're looking at placing a septic tank, they would still have some limitations that they would need to compensate for. And that information comes from the Web Soil Survey, but it's made available through Soil Web and through Google Earth. So that's a pretty cool thing that I think middle school and high school students would definitely enjoy, combining that with geography and learning about their soils. So it looks like I'm going to go back to my presentation here, and we have some questions and answers coming in also. This might be a good time to look at some of those.
So some of our questions, our first one is that where is most organic matter found in a soil profile? In which layer?
Okay, so our topsoil is the most important part of our soil because it has all that organic matter and those nutrients. So we would say that A horizon is the first mineral horizon at the top that's usually darker in color that has that organic matter in it. And of course, you'll have the O horizon on top, which is just the still decomposing organic matter, but the mineral soil, it's the A horizon that has the most. And we really want to protect that part of the soil. You might only have 5% organic matter. The rest is going to be mineral and spaces for air and water, but that 5% is really important there in the topsoil.
Great. Our next one is, do you work in conjunction with or partner with the Rodale Institute to help bring soil education to local areas?
Okay, so I am not a soil educator, and I do not work in conjunction with the Rodale Institute, but they are an awesome resource. Their mission, actually, I don't know a lot about the Rodale Institute, though as a young person, when I was still choosing my profession, I found that they were inspiring for their work in soil sustainability. So there are a lot of private and NGO that are active in our state, and Rodale is an important one that provides soil education and sustainable soils education. I am a federal employee. I work with USDA, and I work with the Department of Agriculture in the Harrisburg State Office. And we primarily provide services to farmers and landowners that are producing food and are partnering with USDA.
Great. Okay, so our next one is, where would you recommend that people can obtain soil samples to show students different soil types?
So I think a couple options. You might consider working with your local soil conservation office to see if they could put you in contact with a farm or a farmer who wouldn't mind you taking just a shovel of topsoil or subsoil. Also, I would look for just any kind of improvements that are going on around your school. So if your school or neighborhood is digging a hole to do an addition or put in a driveway or do some road improvements, you might talk to the person at your school in charge of that project. Or even if there's a landscaper there digging a hole to put in a tree or a fence, talk to the professional, the contractor or the landscaper, and ask them, could you have a soil sample while they're digging that hole?
Great. Yeah, and someone else has also said in the comments too, to check your local soil conservation districts that might have full soil profiles to borrow.
That's a great idea. And that's our monolith, or it's kind of a static soil profile that's been taken and kind of preserved, so that that's a great idea. Many soil offices, soil conservation districts will loan those out to soil education.
Okay, very nice. Well, thank you for answering those questions. If you want to, we have about 7 minutes left. If you want to share more of.
Well, Cassidy, I am done with my presentation. I think I went through that pretty fast, and I didn't want to leave anything out. But I really thank you for the opportunity to share my interest in soils with everybody. But I did kind of breeze through that, and I don't have anything else to share except maybe pictures of soil.
Very good. Well, we can ask for a couple more questions. Does anyone else have any final questions for Melissa? You can use the Q&A box. Oh, okay. What is the map behind you?
This is just a Pennsylvania state map, and it's really helpful working in the state office environment. We provide service to all of the counties and facilitate services to the local county offices across Pennsylvania. So I'm a native Ohioan. I came to Pennsylvania 2 years ago, and it is really helpful to know who we're providing assistance to and where we need to go. So that's like having that state map here in our conference room.
Definitely helpful. What was the site again that you used to use the soil overlay on Google Earth, where you showed?
Yes, it is Soil Web. So I think that's the last page of my presentation, if I can find that again. It's Soil Web, and you'll have a choice of Soil Web Earth, and that either if you just have Soil Web, you can just use it interactively like a website on your phone, just launch the website on your smartphone, or if you choose Soil Web Earth, it brings those soil lines into Google Earth. It will just save a file on your C drive and then just launch, and you can navigate and go.
That's very helpful. That's very interesting. We have also, we have one, what were the 3 main websites? NRCS, Soil Science, and
Right. The Soil Science of America. And the last one was the Pennsylvania Envirothon. So the Envirothon is a great national competition that's statewide. They begin as a state competition and then go on to a national competition for high school students. And Pennsylvania has a website there for coordination and organization of their soils materials there on their Envirothon website.
And all of those, the links to all of those will be sent out with the resource packets tomorrow. So all of our attendees will have them.
Okay.
Is there anywhere where someone can get specific information about specific soil types for specific crops?
Yes, probably 2 things to do. One would be the extension service. So Penn State Extension, and what I would do is look at the crop in particular. So and they would provide a fact sheet for your crop and what are the fertility needs for that specific crop. And then combine that with your soil survey report. So if you made a soil map of your home or of your farm, it would give some information about your soil, and you would kind of compare that. But you also would want to take a soil test, and that would be sampling the upper part, probably the upper 4 to 8 inches of your soil, and you could send that to a soil lab and there understand if you had the right combination of nutrients to grow a healthy crop.
Very helpful. Some of those resources can be great for homeowners and other people. We have a kind of broad one, but how can you improve soil for residential planting of flowers? It might be very broad.
Yeah, there's a lot of soil health stuff out there, and the Rodale Institute, some videos. There's something they call like soil lasagna, and that's just taking the whole idea of compost. I think there's some funny resources out there, but your grass clippings, your yard clippings, the organic kitchen waste, these are all ways to improve your soil. Improving your lawn, there are a lot of chemical but also organic treatments, but a lot of those are just not mowing your grass as short and allowing more shade and moisture to be retained in kind of a deeper lawn. But those are also things that the extension service would be able to provide locally, but also the idea of incorporating compost into your soil and building that topsoil, that organic matter, is a great way to improve your soil health.
Wonderful. And we'll do one last one. Are there any tutorials to learn how to use Subsoil, the resource, better? Do you
So
know
the
of any?
web,
Soil web, sorry.
to use the soil web, I would say just put it in the hands of a 12-year-old girl and boy, and they will just make it happen. A lot of these tools are kind of pointing and clicking. I would go to the web page, and you just you could call a resource soil scientist, and I could get online and explore soils with you. But I say don't be afraid. You want to just kind of click and point and look for things.
Wonderful. Wonderful. Yeah, usually that can help, just looking around things. Okay, so we are going to wrap up. Thank you, Melissa, and thank you, Becca, for joining us today. All of your information was very helpful. For our attendees, we will be sending links to all of the resources that they both shared tomorrow in a email that you all be getting about 24 hours from now. The post-test link is in the chat box. It should also pop up when you leave. And we hope to maybe see you at either 2 p.m. today for hydroponics or a later day. Thank you, and we will see you soon. Bye.